I'm Eric Peterson.
Alex Bone.
That's this chap over here. And we're doing a project on ammonium nitrate. Ammonium nitrate makes me very happy. Um, Ammonium nitrate is an extremely useful compound that has found its ways into daily life in numerous ways. Its usefulness is without bounds, and the versatility of the compound throughout different aspects of society really makes it a focal point of modern living. The chemical and physical properties of this compound create an ammonium nitrate that is worthy of recognition. Together, these aspects of ammonium nitrate compound into a substance that is easily justifiable in the discussion of imperative chemical compounds. So let's learn a bit about it. We're here in Hollis, Brookline. As you can see, this is a lab table. Those are the windows over there. And let's see, let's run along. It's Fox E. Flynn. Oh, he has come to discuss with us. It's lab day.
It's lab day, guys.
That means it's
You
Thursday.
ready for lab day?
Lab day makes me sad.
Why does it make you sad, Eric?
I'm just kidding. It makes me very happy. Oh, we're learning about the best compound ever. Well, clearly, that is ammonium nitrate, and so that's what ammonium nitrate looks like. The molecular structure. The four red circles are supposed to represent the hydrogen. The two black circles represent nitrogen, and the three white circles represent oxygen. It's a bit hard. It's not entirely what it looks like. It's a bit hard because it's a three-dimensional object. The way ammonium nitrate is put together is pretty difficult, but that is fairly close to what it looks like.
What's important is that it's NH4NO3.
NH4NO3. You're gonna see a lot of that today in the lab. All right, going along here. Oh, well, we're gonna learn some more. Gonna grab our lab jetpacks.
Those are very convenient.
Oh yes, lab jetpacks. Every lab has them. We're learning about the density of ammonium nitrate, which is 1.72 grams per cubic centimeter, and the molar mass is 80.04 grams per mole. That's what we have going there. We're gonna make ourselves this way the grand unveiling of ammonium nitrate. So at STP, as you can see, ammonium nitrate is a solid, and that's actually what it looks like. It's small, white, very reminiscent of Dippin' Dots. But don't eat ammonium nitrate. It is not delicious.
Dangerous stuff. If you do ingest it, force yourself to puke.
Yep.
It's the best way to save yourself.
Yes, the only time we're ever going to tell you to puke. To force yourself to. Oh, wait, Bone, I just realized something.
What?
We're not being safe in the lab. Oh. We should get on our lab gear. Gonna go down here. Got some goggles. And an apron. I believe I'm safe.
This looks safe to me. Won't catch on fire.
I believe you have a gorilla suit on.
Whatever gets the job done.
Alright, whatever gets the job done. You heard it here first, folks. Alright, and that's good we put our lab stuff on because we're going to learn about the environment and how it affects ammonium nitrate. We're going to step into our freezer. So there we have a piece of ammonium nitrate, NH4NO3. And it's obviously solid at STP, but the freezing point, or melting point, depending on how you look at it, is 169.6 degrees Celsius. So obviously that doesn't necessarily mean that it's covered in ice, but we thought it was a nice little touch. 169.6 degrees is very hot. Even hotter is 210 degrees Celsius, and that's the boiling point of ammonium nitrate. Someone's boiling some ammonium nitrate in a pan.
It's a hot pan.
For who knows what reason. So we're gonna go over ammonium nitrate. Isn't a very reactive substance, but it does do a little bit. When placed in water, it produces a mild acid.
It's part of what makes it so useful is its general stability, versatility, and easiness to control.
Right, and we're going to discuss that a little bit later also. Here we got a Bunsen burner, carefully lit. But ammonium nitrate isn't even flammable, so there's very little danger involved in this lab. One interesting thing, though, is the way it affects fire. So if you were to add ammonium nitrate to a fire, it wouldn't catch on fire, but it would increase the fire.
It is an oxidizing agent. So, like we said, it's not flammable. It itself will not catch on fire. But when added to a fire, it will add oxygen, a key component of fire, and it will strengthen the fire, make it larger, harder to deal with.
Yep, and so that's what we got going on there.
If you need a fire extinguisher, ammonium nitrate is not what you want.
All right, it's explosive when under great heat, or temperature rather, and great pressure. So, really, I guess gotta be careful. We're gonna come down this way. We got a big cart of it, NH4 and O3, like I said, you're gonna be seeing a lot. Get out of the way. Bam. That's an explosion right there.
Kaboom.
You gotta be careful. Whoa, hop onto the chemistry, history, time traveling spaceship of science. Well, I think we're gonna have to take a ride.
Sounds worth it to me.
Yep. Oh,
I left you.
okay. We're gonna, that's an elevator.
You ready to go or what?
Yep, alright, here we go. This spaceship looks like a book. I guess books can take you places. Alright, let's go. Hold on tight. This is what it's like to go back in time, by the way. It's very funky. Whoop. I'm gonna come up here.
In front.
Alright, so we got a timeline. Here, we have the self-proclaimed Johann R. Glauber. And he was a 17th century alchemist, and he was spurred to find an explosive substance besides saltpeter. You want to talk a little bit about saltpeter?
Saltpeter is an extremely important substance. It's also known as potassium nitrate, and it's the main component of gunpowder. So, at this time, Europe relied on saltpeter, and it had it imported from Chile. So we wanted to find something that was more abundant, easier to create, and easier to use. And he happened to stumble upon ammonium nitrate, which was extremely useful, but at that time, extremely hard to produce in large quantities.
So after that, ammonium nitrate more or less fell off the radar in terms of development, just because of the restraints of how much could be produced at any given time. So it took a while, a couple hundred years, and then in 1910, these two German scientists, Fritz Haber and Karl Bosch, they created a process called the Haber-Bosch process, creative name of course, to industrialize the production of ammonium nitrate as an explosive for war. Do you want to maybe go into a little more detail?
The big thing here is that there's a lot of nitrogen in the air, but currently we were unable to use it. So the Haber-Bosch process was able to take the nitrogen from the air, fix it, and make it usable, therefore not relying on expensive imports.
Right. So that's these two guys you see up here. That is exactly what they looked like. And so now we're going to go over here and learn a little bit